handle it from here.
Awesome.
On Ethernet IP networking.
Yeah. Afternoon, guys. So most of you know me, but my name is Luis. I'm the solution architect with Rockwell out of Houston. So for you guys in the room, for anybody that's on the phone, just ask questions as throughout. I don't have a lot of slides. Figure we'll talk through some of the application set stuff. So if you guys have a question and we veer off a little bit, perfectly okay. Main thing I wanted to kind of cover is some design considerations when we're looking at networks. That could be anywhere from kind of the IO network, the control network, process control network, or even looking at the managed switch network when we're tying into HMI, historian, anything that might be part of that process. So I won't get too deep on a lot of these things, but one of the things that you'll kind of see from us on the Rockwell side is we talk heavily about white papers, reference architectures. So a lot of the guidelines and everything that we put forth on it comes and is tied in with what we do with Cisco, with Panduit, and looking at the different type of architectures, both from inside of the panel through the entire site, plant floor, even into networking, going into a business network side of it. So a lot of the times if somebody's trying to do remote access or tying in, sending data up, even to Wayne's point earlier about the IIoT, we start looking at how do we get that securely up. So that might be security, firewall, DMZ, those type of communication. So you'll see, I like the kind of feature set there, architectures, a lot of like quick little one sheet documents that you'll see on our website, just talking about how do you go about or why would you use a specific piece of hardware. It doesn't get very deep dive, but at least gives you kind of an idea of what the architecture should look like. And it goes down all the way to what's called the Converged Plantwide EtherNet Guide. That's a 500-page document that starts you off with any type of reference architecture you can think of, including wireless, firewall integration, and then there's also about 20 different addendums that have been coming out specific to DLR, like device level ring. We start looking at wireless design guides. We also have information on that traversing that DMZ when we're trying to do historian traffic up, not putting a controller on your internet network, those type of things. So if there's anything that you need, one of the things that we put together, both me and Wayne, you guys have access to these after this session. There's a little appendix section that has tons of different links that you can download all of these. So everything's on our website, but we'll make it easy for you guys to have access to it. So a couple of key tenets that we're gonna cover. There's a lot here. Mainly what I have highlighted is kind of what we'll go through. The main thing here is we're talking about your controllers, your IO, your switches, your industrial network when it comes to like visualization, HMIs. So how do we kind of safely look at that from a design point of view? So one thing is a managed infrastructure, looking at unmanaged versus managed switches, and particularly on our end, on the Rockwell side, you'll hear Stratix switch from us a lot. So Stratix is our managed switch. We do have an unmanaged line, so it's a Stratix 2000. That's your simple like 5-port to 16, 24-port. All that's doing is connecting into your network. Usually that's a kind of isolated network. We're not really doing a lot with it. Then we have our full managed lineup, and that'll be our 5700, 5800, the 8000s in the past. So those will be layer 2, layer 3. We'll kind of go through benefits on that end. Segmentation, being able to separate out your IO network from your control network, from your HMI network, why there's benefits to that, anything that we might be looking at it. Also VLANing is the other concept that goes with that. And then how much redundancy is too much redundancy when it comes to network. So looking at a single device, do I need to have dual networks that are going up? How do I handle that? Do I want to be able to survive if one of my Ethernet cables gets pulled? So there's a couple other things that we'll kind of touch on at the end of it, but those are kind of mainstay what we'll be featuring on. Like I said, if you guys have questions, just feel free. Any of you still using unmanaged switches? We got 2 people that we have to yell at. So all of us, no. So a couple of things that you'll see there, we have the idea of managed switches. So those are, again, your larger end switches. You are spending more money for those switches, so they're not realistically a commodity item, but at that same token, some of the things that happen is when you have an unmanaged switch, what ends up happening is you put that into the cable, let's say it's a 5-port unmanaged switch. Any traffic that goes into it, so whether that's control traffic, HMI traffic, is now available on all the other ports. So it's the equivalent of me being in a room here trying to tell somebody on the other side of the room and everybody hears the conversation. Whereas a managed switch, because of the fact that I can either do quality of service or different layers there of diagnostic, it'd be like if I'm whispering to the person on the other end of the room, nobody else hears. So you are able to define the traffic. You don't have to be kind of adding everything on. So an unmanaged switch, the biggest thing is if anybody's ever taken a cable that's loose in a panel and plugged it back into the switch, not knowing where it goes. An unmanaged switch, if you end up closing that loop, creates a broadcast storm and the entire switch goes away. A managed switch, if you do that exact same thing, only that port dies, not the entire switch. So that's a huge benefit there. That's that loop prevention piece. There's no security and there's no diagnostic on an unmanaged switch. You have no idea other than the little blinky light in the front of the unmanaged switch to tell you whether or not something's working, what the speed is, what might be having issues on that. So no diagnostic, and you also can't really do any of the higher level architecture side on an unmanaged switch. For the same reason why you can't create a loop, I can't take 2 cables and go to the same network as a redundant star or ring topology on an unmanaged switch. So as your system gets bigger, you almost have to move everything over to a managed switch, which is typically why in like a process control network, you'll see no unmanaged switches. So the other concept that we'll talk about a little later is embedded switch technology. So we call that DLR, device level ring. Most of our equipment from a Rockwell point of view has 2 ports on it. If you ever see that, typically what that means is 1 IP address, 2 physical separation ports, but it's basically a linear or ring network. You don't need a switch. So you can daisy chain devices back and forth, and we'll have that either in the back or I'll show you a couple pictures. On the managed switch side, so now I do have diagnostic information. So everything that's tied into my managed switch, I have a link diagnostic piece that's telling me exactly what's going on. And for the information that's passing inside of that, whether we're looking at a copper connection via patch cable or if it's a fiber connection, I can see what traffic is going back and forth. So I at least get to see how much traffic is going in, what the throughput is doing, or if you have a bottleneck. So that's kind of one of the benefits there. You do protect yourself if you do a loop. You can now segment traffic. So one of the benefits here on segmentation is if you have an IP camera system and you have your control system, your IO traffic, and maybe some power MCCs, they can all be segregated where they're not all talking to themselves. So if you have an IP camera system, you don't have to worry about that IP camera system interfering with your control system. So that's the big piece. It could be the same physical switch, but you segregate the traffic so they never collide. So that's a huge benefit on that side of it. You also do get some security and some managed systems, but those are kind of like the key tenets. So when we look at it, on the Rockwell side, Stratix 2500, 5700, 8000, 8300, 54, all the way to the newer 5800 that we talked about last month. So those are all of our managed switches. So power over Ethernet, or PoE for short, 5700, a little bit on the 8000, 5400, and the 5800. All of them have it. In most cases, just there's separate catalog strings on some. On the 5800, it will come standard for like, I think almost all the ports. But the 5700, there's 2 or 3 specific catalog strings that'll do power over Ethernet. Yeah. So some of the benefits that you get here, like I said, you get diagnostics. You also have the ability of being able to see the topologies. So if I get diagnostics, I can also tell you what's connected to it or where it's going. So as I connect multiple switches together, or I connect the switch to, let's say, control logics or compact logics, I now have tools in place that can tell me everything that's there and even give me asset information if I want to. So there is a huge benefit on that end when you're looking at a managed switch technology. The ability of being able to do switching. So that means you can now support multiple IP addresses or different VLANs, different subnets. So a lot of the times what you might see is your DCS is a 172 dot address range. Your power equipment might be a 192 dot address range. If you want to still have that segmented, a lot of the times, especially in the past, you had to have different switches for each environment and then home run everything back. Now what we can do is take one switch, segregate, do that segmentation, consolidate everything into one switch, and then trunk that cable so that one Ethernet cable going up has the ability of swapping between the two. So you can now kind of define your architecture and do, usually what we'll see in ours is if there's a bunch of panels out, each one may have a control logics or a compact logics, you put a managed switch in each one of them, and then you centralize everything back into a larger distribution style switch. And you can either do ring or redundant star. So now I'll show you a couple of examples of that.
When you segment it,
Mhm.
is it segmented, the connectors, can you plug in any connector, or that when you segment that, the segment has these?
So what you typically do when you're doing segmentation, and I'll show you some pictures, is you do it per port. So let's say if it's port 3, you can tell that that port will be VLAN 10, let's say, or specific to the IP camera system. So if you take your laptop and you plug into port 6, you can also define that that same port is for the same network. So it's almost like making a connection via the back portion of the switch. One other huge benefit of a managed switch design is the ability of doing what's called quality of service. So one of the things that we promote on the Stratic switch lineup is, typically speaking, when you're talking on a managed switch or just network in general, a lot of times IT gets involved. And if you think about it from a traditional IT point of view, a lot of the times voice over IP has your highest priority. So quality of service is an easy way of thinking of packet priority. So as you're thinking about it, what information that you're passing through that network has your highest priority? When it comes to the control network on the Rockwell side, our highest priority goes to SIP, that Common Industrial Protocol, or Ethernet IP. So the communication that you have peer-to-peer from one controller to the IO or controller to controller has a higher priority than that of an IP phone, IP camera, things of that nature. So the quality of service actually takes and understands the information that you're sending via those packets. So the information that you're sending back and forth via the switch, and can assign a quality or a priority to it based on what it is. So by default, all of the Stratic switches are set up inverse to that of standard IT, where you're actually getting a priority, a higher priority to everything in the control network side versus what you would typically see on an IT network side. So think of your laptop, voice over IP phone, things of that nature. So this is a huge benefit here. So everything you see kind of on this picture here will have a higher priority versus a standard IT network. The other benefit that we start looking at is DHCP. So I always have to remember what the acronym stands for. So the dynamic host there, what that's talking about is, if any of you have ever used your laptops either at work or your home network, most times you plug in either to the wireless or you plug in your Ethernet cable, you automatically get assigned an IP address. You don't have to do anything, and you can now access your email. You can get onto the internet. What's happening in the background is something somewhere is assigning you your address based off the authentication that you tied into. So in your home router, when you connect into the house, you're basically automatically tying into that one little router box that you set up from AT&T, Xfinity, whoever that might be. It gives you an IP address. You can now use the internet. Same thing happens here at the managed switch side of it. You can now assign an IP address range for your process control network based on your port. So what the benefit there is, If you take, let's say, an E300, a VFD from us, or even a controller, and you want the IP address assigned by the cable that you plug into, if something happens to that unit out in the field, I can replace it in kind, bring in another PowerFlex 525, pop in the same cable, and force feed the same IP address to it without having to configure it manually. So you don't have to get on the HIM module, you don't have to do anything. And if you guys have heard automatic device configuration from on the Rockwell side, the controller at that point, because the IP address matches, controller now sees that the configuration of that VFD is off. It will push the firmware, it will push the configuration, all the parameters will match up, and you no longer had to do anything to the drive. It's automatically back how it was because of the fact that you force fed an IP address to it. So you can do that via switch. A lot of times people do that from the servers, but when you're looking at a managed switch environment, all of that can happen because of that. Unmanaged switches, obviously you can't do that. You're not assigning any of the points. So a little bit more on the segmentation side, and kind of the reason why we promote this is when we start looking at it, as your systems start getting bigger, whether we're looking at either a process skid, a panel, a full plant or factory floor, the more controllers, the more smart devices, like Wayne was talking about that, the IoT kind of idea, all of these devices from our drives, from the E300s, the buckets on the MCC, all of that has diagnostic now. So if you think about it, that's a lot of information that's being force fed into either the control system, your historian interface, the HMIs, panel views, anything that's out there. So what we start promoting is the ability of being able to segregate this information so that they're not always on the same pipe. So back in the day, we used to have like control net, device net, everything was dedicated. You didn't have as much of a large pipe that you can actually send everything through. So you didn't have to worry about bottlenecks. You didn't have to worry about throughput as much because it was all a dedicated network. I now have Ethernet that I can send as much as I want. And if I wanted to add a panel, all I have to do is drop in an Ethernet cable, and all of a sudden I have more information that's on my controller. So what I can do, and what I typically do, is, especially in Contrologics, I segregate and put 2 Ethernet adapters, one for my control network. So this would be all of my IO. So I can have point IO, flex IO, Contrologics IO, all dedicated on the bottom. I'll have a secondary Ethernet adapter that's dedicated only to my HMI and my historian traffic. So when I'm connecting via Studio 5000, I connect into this first card so that I can do all my configuration changes, do everything that's there. The controller is always using this 4th card to be able to do its IO traffic. So anything that I do on that first card is never affecting the traffic that I'm doing for the IO. So if I'm sending a command to a pump to turn on, I don't have to worry about what I'm doing on the top end side. I don't have to worry about how fast my historian is pulling. If I decide on my system that I'm going to add, let's say 30 sections of MCC, whether it's low voltage or anything else, I could potentially just add another card and have that segregated out so it's on a completely different IP address stream. If I'm doing redundancy, realistically, all I'd end up doing is having 2 of these, chassis A, chassis B, and have the same segregation. So what you'll see, especially on that Converged Plantwide Ethernet guide that I was talking about, it talks about how to do that. Technically, will it work if you don't separate it out? Yes. So you don't have to, but it's one of those things where if you plan it up front, it makes life a lot easier. The other thing that you can also look at is one of these cards may be dedicated to, let's say, Modbus. We were talking about HMS earlier. If you get an HMS, ProSoft, Molex, a gateway card that goes in chassis, you're already doing that segregation on the third-party equipment. On the top end side, the Rockwell controller doesn't care. It just brings in the data points directly into the processor, and it can be collecting data from 3, 4 different Ethernet adapters. So the other way to do the segmentation, and this is just part of it, is when we're looking at it, typically when you're doing the different subnets, you end up doing like the 192, 10.172 different address ranges. You're dedicated to each one. So typically what we do on a managed switch environment is we do virtual LANs. So it's VLANs for short. What this does is, to your point earlier of how do you do the segregation on the switch, I will do a specific VLAN. So it's almost like a grouping code that I put inside of the managed switch. And I say this VLAN 40 will be a flat network so that, let's say, ports 1, 2, and 3 are always part of this subnet. And in this case, this is the 172 address range. Well, I can also say that the other ports on there might be dedicated to something different. So this may be in terms of if you got contractors that go out, or if you have specific type of equipment. So think of like the IP camera that I was talking about. If you want that on its own dedicated network, you want to be able to take advantage of the same switch, you can make multiple different VLANs. Each VLAN would be its own subnet, all tied into the same switch. The layer 2 switches, so 5700, the 5400, the 8000s, all that means is you're switching between the same networks. So if you put a VLAN, you dedicate each specific port to whatever equipment that you're tying into. And if you plug into another port that's not on the same VLAN, you can't see it. You can't ping to it. It doesn't matter what you try to do. You're segregated from that network, almost like if it was a physical switch. What you would need to do at that point is have a layer 3 switch that allows routing. So instead of just your switching environment, there's now a switch dedicated to route that traffic. And what you do at that point is if I have a 10 dot on my VLAN 10 and a 172 on a VLAN 40, traffic would go up through the layer 3 switch. You would put a rule in place to say allow that routing. And at that point, I can then ping. So the layer 3 switch would be the 5400 from us, the 8300, or the new 5800. So we would have one of these on the top end network. This is usually probably what you have in your control room. So that could either be just a single switch, or it can be more of a distribution style switch. And then all the switches in all of the different panels would be your smaller end layer 2 switch. That makes sense? Go for it. Yeah, when we look at the topology, ring is an option, redundant star is an option, and actually I got a couple slides that will talk about the different options there. But yeah, all that ends up happening is the total number of ports that you put on the switch. You can put them either single VLANs, multiple VLANs, and all that's doing is just segregating the traffic so that it doesn't collide with each other. So, and what you do with the network after that, whether it's a fiber connection or a copper connection, is it don't care as long as it's coming out of those specific ports. So, good lead in. So we'll cover the switch level side of it first, and then we'll get into a little bit on the device level ring. On the switch network, so if you're on a managed switch, you do have the ability of being able to do the upper end architectures or the topologies. So what we generally see is the easiest one is a star. All that means if I got a 5-port switch and it's a managed switch, those 5-port connections can be tied into any device that I'm looking at. What ends up happening is it's a single cable. So I got a single port that's going to control logics. If I lose that cable in between, I have no communication to the control logics. As simple as that. It's the easiest to implement, but it doesn't have any protection whatsoever usually when it comes to loss of cable. If I'm doing a linear connection, I'm doing a daisy chain in between, but again, if I lose a connection in between those pieces, I can only see what's on the top end side. A ring network, this may be either what's called REP, Resilient Ethernet Protocol. It might be device level ring at the switch level side of it. All that is a daisy chain between the switches. The benefit here is if I lose one connection, I'm still communicating on both ends. So now you add a little bit of complexity because you actually have to close the ring. So typically we test this up to about 24 managed switches in a ring topology. And then everything underneath that, you can either do, if this is a 5700, if each one of these are, that could either be a star to the independent connections. So inside of a panel, you're doing a ring from switch to switch, but inside of the panel might be a star to the panel view, to the control logics, all those items. Or you might even do a ring inside of the panel and still do a big gigantic ring to the switches. So you can mix and match. But again, at this level, it's a little bit more complex, a little bit more cabling that you have to run. And the big piece that you have to worry about on this side is if you guys are putting something new in, you have to kind of be conscious of where the cabling is going and where power is going. So think of this drawing, this might be a little difficult for the people on the phone. If I go through the switch and the two switches that are on the bottom are not put together at the same time, and I do the ones on the left and the right, that ring doesn't close. I can only see these. So if this grows and I have 10 panels that I have to deal with and 3 of them in the middle are not terminated at the same time, or I don't have power, I can't commission those back to the main network because all of a sudden I can survive one break. I can't survive 2. So if I lose this one cable on the left-hand side, I'm perfectly okay. But as soon as I lose another cable, I only see what's tying back into my top-end infrastructure. So you just have to kind of mitigate that when you're doing commissioning. Outside of that, once it's installed and once you're configured, it makes things a lot easier. Kind of the preferred, at least on my end, just because it makes things simple, is a redundant star topology. So this now answers the question, how do I get redundant network connections? So I'm running 2 cables. So even if I lose one lead on this, I'm still communicating to the switch via another connection. And I don't have to worry about how I'm doing commissioning because I can have each one of them tied in. So if I lose a cable, I'm basically just at a star network. If I have both cables on, it's a redundant star. The biggest issue that you'll see with this is it requires double the pool. So whether you're looking at fiber networks or if you're looking at a copper network, you have to pull double the cable. So you just kind of have to mitigate that. The biggest piece here is how critical is infrastructure to be able to bring that information up. If typically speaking, one of the things that you may be looking at is if I lose my network connectivity, I want everything to go to a safe state. So you might have control logics up top, remote IO at the bottom. If you lose network connectivity, have everything go to the safe state. You don't have to worry about it. At that point, it's not that critical. You can probably do a standard star. But if you need something to continue working, then you either invest in a compact logics that goes in place of that remote IO, so that if I lose the network, the compact logics is tied directly to the equipment, continues to function, and all you're doing is a peer-to-peer communication. You can care less. Let's say if the network dies, because as soon as it comes back, you know all you're going to do is get the diagnostic information. But on that same token, if you want to make sure that your communication is always solid and you have an option between an active and a passive kind of connection, then you do either a redundant star or a ring topology. So those are kind of the application level ideas that you have to kind of question. What makes sense and the fact that you can kind of mix and match. How do you what? Mm-hmm. Yeah, typically when you're looking at redundancy, you almost always, the easiest one to look at is a redundant star. And then the other thing on our end for the control logics, you already have 2 chassis. You got a chassis A and chassis B. Typically, you want to make sure that you follow suit with that as much as possible. So if you got a chassis A and chassis B, and you tie everything into one switch, you're still kind of limiting your system. So what ends up happening is you typically do a chassis A, chassis B, have its own dedicated switch up top, And that might go into a larger infrastructure, either a redundant star or some type of topology there. And then you would typically do, when you have a chassis A, chassis B, do a DLR ring on the bottom end side, so it still connects chassis A and chassis B on the network side. So that way you're always protected, and that if you lose a cable above or below the control logics, you're still communicating to everything else. So, any other questions? You guys on the phone, don't be shy. You guys can ask questions. Yep. So you can, the only thing that you have to watch out for is if you try to mix and match cabling schemes is the speed. So a lot of the times, especially when you guys are looking at managed switches, the copper connection or the patch cables can go up to 300 feet. That's kind of the limit of the actual Ethernet cable. Now, if I have something from here to another location and it's 500 feet, the easiest thing you can do is put a managed switch or some type of switch environment in between. And I got 200 feet on one side, 300 feet on the other one, and I'm perfectly fine. Because as soon as another switch is there, it acts as a repeater. What ends up happening is the speed of the ports are either going to be 100 meg or a gig. What you don't want to do is you don't want to mix those speeds because it's always weakest link in the chain. So if I go gig, 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 100 meg, gig, everything is 100 meg. I don't care what kind of cable you pull. If you remember Best Buy where they had like the gold plated cabling, doesn't matter. So you can do a mix between copper and fiber. It's just the speed. So as long as you're not mixing speeds, and you probably have always run into this with like auto negotiate on some of the things, that's what's ending up happening is you define the speed based off the port. So like the 5700 is a good example where a 10 port switch, the 2 ports that are uplink are called combo ports. Those are at a gig. So if you think of your laptop, those are at a gig. The other 8 ports on a 5700 are 100 meg. So typically speaking on the Rockwell side, almost everything that we have is 100 meg. We've now implemented the L8 control logics, so the 5580s and also the 5380s, the newer compact logics, those are all at a gig. So the 5700 switch that's only 2 gig ports and 800 meg ports may not work for that architecture. So if I'm able to consolidate everything into the gig port and then just do an uplink, it's perfectly fine. But if I plug in an L8 control logics that has a gig Ethernet port to a 100 meg switch, that's a 100 meg network. Doesn't matter what you try to do. So it doesn't matter what you're pushing out. If your fiber connection or your copper connection is 100 meg, that's your limitation. But you can mix and match all day long. And then the other thing to think about when it comes to a switch environment is on the fiber side, you have multi-mode and you also have single mode. You don't want to mix those because there is a different technology that kind of goes in between that. But there's no issue as far as speed is concerned. You're not going to see different throughputs when it comes to multi-mode or single mode. Realistically, that's all distance and future-proofing more than anything else. Yeah.
Just on the architectures,
Mhm.
can you still start with 100 and then as you go up, you have bigger size ports, a bigger size switch? Does that still make it 100 MB network, or does it still, it qualifies as a gig network on the top and you have 100 MB switches on the bottom?
So you can, so the idea there is topology wise, let's say we have 5 panels and everything's connected at 100 meg. And then I consolidate everything to a top end network. So similar to this guy that, let's say we're doing this. So if these connections are all to 100 meg, if I want to consolidate everything and tie into a gig network once I'm at the top and everything above is now a gig, it doesn't minimize the 100 meg, but the expectation is the information that I'm getting from my point IO is never faster than 100 meg. Even if you have a gig topology up top, But the benefit there and the reason why the managed switch network gets powerful is, think of the segmentation stuff I was talking about. I now have point IO, which is at 100 meg. I have my IP cameras that might be at 100 meg. I have my control logics that might be at 100 meg. But I now have a pipe that's a gig or more going to the top end network. So even though I might not be able to make that fast enough, because my pipe is large enough to be able to take all of those strands of data and send them up, that's why you want to have that top end network be at a gig infrastructure. You guys good with this? So this is kind of covering from a switch network side of it. So like I said, this would be tying in, once you're past the control logics, you go to the switch network, you go up. Typically speaking, we're looking at redundant star, or ring topology. The kind of the default that you want to get to is redundant star, but just look at the application set and see where it kind of makes sense. What kind of cabling do you have? How you're going to pass that traffic? And then especially if you start looking at servers, computers, panel views, anything that you might have on that network, how do you want that to get the information out? So those are kind of the top end side.
For redundant star work, you have to have a router.
Not necessarily, but you almost always have one if you're doing the segmentation. So if everything is a layer 2 switch, I can still have this traffic, this be layer 2, this be layer 2, and this just be a flat network. The redundant star will still work, but a lot of the times what you end up doing is you'll have a distribution switch or the top end switch is on top, and you want to be able to do some type of segmentation. So that's when you'll have the router. But just for redundant star to work, they can all be a layer 2.
And also to segment in the ring, you don't have to.
No, same thing. Only if you're changing IP addresses do you need something outside of it. If you're doing the Cisco-based technology, so this rep, that can support multiple VLANs on the same trunk. So you can still have a switch that has, let's say, 3 separate IP addresses. Each switch can all have the same thing. And then that single cable can just transmit the information back and forth. You would need a router on the top end side if you want to be able to jump between the IP addresses. But if you wanted it all just segmented, it's all layer 2.
So I've got a ring with 10 switches.
Mhm.
They're all not introns.
That's your problem. Okay.
On switch 1, I got a compact logic controller, be a big overall switch. So I can segment that.
Mhm. Yep.
Everything on it's the same.
Yep. One of the things to keep in mind that sometimes bites people is if you're doing segmentation, it has to be in a completely different subnet. So I can't segment, let's say the 192.168.1.20. I can't segment that from 192.168.1.40 because they're on the same subnet range. They're on the same kind of flat network. I have to, that third octet has to be different. So for me to do the segmentation, I have to, even if I'm doing the 192.168.1, 192.168.2. That would be my first VLAN and my second VLAN. But I can't segment the last octet because they're always on the same chain essentially. So just keep that in mind when you're doing it. I was trying to get tricky on network address translation and kind of bit me. So I'll still be here so we can still kind of run through a couple different architectures, but when we start talking about below control logics, typically speaking, this is, I look at DLR or device level ring as more of an IO network. We do have the ability of having the static switches dedicated directly for DLR. So that ring topology doesn't have to be the Cisco base, it could be ours. So one of the things that you'll see in device level ring, like any ring network, it's a single fault tolerant ring. It means that I can lose one Ethernet connection and still be talking to every single one of the devices. I can support up to 50 Ethernet IP devices. without the need of a switch. So I'm essentially doing daisy chain between Contrologics, panel view, flex IO, point IO. Essentially every single family that we have supports DLR. It's easy to implement. You do have to worry about the ring, so you have to kind of close that loop. We can support just your standard patch cables, the 300-foot Ethernet cable, or we can do multi-mode fiber. If you're using a managed switch, at that point we can do fiber or single mode or multi-mode. If we're doing just the device level ring and no switches, we have access to what's called an ETAP that can do multi-mode fiber. So I can come in copper on one end, go out fiber on the other side, multi-mode. And again, I can do 50 of those devices. The big benefit here is because it's on a Rockwell side, the reconvergence time, basically the amount of time it takes for it to fix itself, is within 3 milliseconds. So even if we're doing redundancy, the speed that fixes itself is faster than the controller talks to the IO. So at no point in that will you see any of the nodes drop, but you get diagnostics telling you where the break happens. So what ends up happening is you set up your up to 50 devices. You would set up what's called an active supervisor. That typically, my recommendation is that typically is the most expensive piece of equipment that you have on the network. So on that chain, so you wouldn't do the ETAPs. You would generally do the Contrologics with the Ethernet adapter, one of the static switches. One of those would be your active supervisor. That's the one that goes out and checks to see if there's any breaks in the chain. And what ends up happening is it will automatically block the second port. Like I said, there's 2 ports on that card. So there's it's one IP address, one MAC address, 2 segregation points. So it's sending traffic out one, it blocks the other. There's a little beacon that goes out that makes sure that everything is still there. It's getting its information back within like a millisecond or so. If it does see a break, it will automatically open that port. If it sees a break at this low end chain between the IO, it opens that port and you can now have a linear network going throughout. So that active supervisor is the one that's providing you all the diagnostic back and forth. Some of the benefits on this end, both from a panel view and also from our Factory Talk View SC platform, the Studio 5000 environment for the Contrologics and Compact Logics get diagnostics from this natively. So there's a little add-on instruction that you can drop into your code. This is a faceplate that you add into the HMI. Everything that you see inside of it will automatically get populated. So it will build the DLR chain for you. Granted, assuming you drop in that little AOI block. So for anybody that doesn't know, an AOI is just an add-on instruction, little black box of code that we provide to you. It's on our website. You can download. What this does is it not only tells you your network supervisor, it will assign and tell you what any of your backup supervisors, because we do have those in terms of it. It will provide you a status uplink. It will tell you where the backup supervisor is located, and it will tell you the IP address and MAC address of every single one of the devices that are there. DLR, device level ring, is a standard that's built off of ODVA, which is the same group that owns our Ethernet IP Common Industrial Protocol set. So it's a full standard. So anybody that creates a device that supports device level ring follows suit with this. So the big benefit here is if I get a break between my flex and my point IO, it will tell you what the IP address is between the breaks. So even though all of your devices are still talking in the network, it will at least provide you diagnostics and tell you, okay, this is where you need to fix it. So that way you can go out, fix that network. As soon as you fix it, it'll automatically just propagate and show up on the system. So this is what you'll end up seeing, fault location. Some of the other things that we've added on our end when it comes to the device level ring is the ability of being able to assign DHCP addresses. So I talked about DHCP as an option for a managed switch environment. What we've now done is typically we'll take all of the devices that you put and you do static IP addresses. Because how often do you actually change the IP addresses of your like .io drop? But if it makes sense, especially a lot of the drives and those, any of the devices that you get from us will either be BootP or DHCP enabled out of the box, meaning that they're waiting for you to provide them an IP address. So what you can do as part of the device level ring is, if you have a managed switch on that network, you can now say, I have 50 devices on this chain. Ignore everything that has a static, but everything else, here's the address that I want you to give. And essentially, it's a little table that you create inside of the switch so that it says, in this case, index. So device 2, device 3, device 5, here are the IP addresses. So every single time something gets plugged into this network, if I got the VFD, I can now do that automatic device configuration on.
So basically, this port is basically reference to port,
Mhm.
gives the IP address to that particular device, no matter what device you put there.
Yep. So granted, you do have to take into account where it is on the network. So because it's not it's star network, it's a ring topology. If you got 50 devices on there and all of a sudden you say, oh, okay, well, I'm just going to remove this one device, you're changing the node count and you have to replicate that in your text. But if you have the 50 devices and you're going to take this out and replace it with either something in kind or maybe an upgrade, that IP address will always be the same IP address. The other benefit that you also get with this is called redundant gateway. So we were talking about how much redundancy is too much redundancy. If you're doing a ring topology underneath and you have defined requirement that you have to have 2 connections up to a top-end network, what the device level ring allows you to do is put 2 network switches on there and have one be active and the other one be standby. So if this is your active on the right-hand side, communication going up to the top-end network is flowing through. If something happens to that switch, this connection is usually blocked. It'll automatically open up and ignore that first switch. And that's just a setting inside of our managed switch on the static side of it. So this just gives you a couple of options. Again, we can do redundant star, we can do a linear topology, but this just gives you an option if you're wanting to pull something into the top end side.
Managed.
Correct. Yeah, to get any of the fun feature sets, you'd have to be on the managed side. Yes. Yeah, so we have a couple different classes and we'll pull them up on the side. So we have like a day or 2-day courses that are just specific to getting into a static switch. We do a lot of classes during tech eds and automation fairs that are kind of like a little 2-hour lab if you just want to kind of play around with it. And then we have full 4 to 5 day courses that are shared with Cisco, where if you want to get deep dive into programming the switch, configurations, topologies, even getting to the point where you want to do a certification on the network side of it, we have those as well. Any questions on device level ring? So this is a newer feature, something that's probably within the last year is starting to take hold. So parallel redundancy, or PRP for short. So this is another ability of being able to do the same type of networking ability, but the difference here is instead of a ring topology, I'm looking at 2 ports sending the same data out both connections. So similar idea to the redundant star. It might be easier to implement. There might be more pieces that I have to deal with, but now if I lose one leg, I'm still communicating off the other. So this is a standard that we see. So this IEC standard, that's 62439. So anything that's built off of that uses that parallel redundancy setup. This is probably closer akin to if anybody's ever done the older control net style where we had channel A and channel B. Same idea. Instead of I have 2 ports that are coming out of the control logics adapter. So it's an EN2P card. 2 ports, channel A, channel B. I'm communicating and I essentially are sending the same piece of data out at the same time, goes down, gets received at the bottom end remote IO, Whichever one gets there first wins. So in the device level ring, I talked about a 3 milliseconds reconvergence time, how long it would take to fix itself. This is bumpless. Because of the fact that I'm sending the data out both sides, whoever gets there first wins. I don't care if I lose the second switch. I don't care if I lose the second leg. Communication is still going through back and forth. So what ends up happening is I have two separate packets that are being sent at the same time, just a LAN A, LAN B. If you can look at this, one of the things that you'll see is for this to work, at minimum, I'm looking at two switches in between the network because I have to be able to segregate LAN A, LAN B. That lands into one switch. These switches here in the middle don't have to be programmed any differently. The only big thing that would be a no is if I would run a cable between the first switch and the second switch. I can't do that. I have to keep them segregated. So that's my LAN A network. This is my LAN B network. If I lose this, all my communication is on my blue network. If I lose the first switch, all my communication is on the yellow network. The caveats and the things that you guys have to keep in mind, if this is, typically we see this more in proposals for utilities. They want that bumpless transfer, so they end up putting this as part of the network. We can support it in Contrologies and Flex 5000, so that new lineup. What you have to keep in mind is, if you look at this guy here, if I add a panel view or any node to a single switch that is communicating, I can see my HMI graphics. If I lose that switch, my LAN A network is still working. Communication between the controllers and the IO are still working. That switch is gone. That panel view is not seeing anything. So for any type of device that doesn't natively support the parallel redundancy, what we end up doing is called a red box. So the architecture term there is a redundancy box. So the switch that we would be promoting on this end would be the Stratix 5400. What that does is kind of same idea as an ETAP. If I'm looking at a device that doesn't support it, but I want to be able to add it into the network, if I add this panel view or these individual devices directly into the redundancy box, I can send the cable to both LAN connections. And even though that was a non-parallel redundancy box, it now has a tie-in to the rest of the network. So if I lose LAN A, I'm still communicating to everything that's there. And I can make, if this is a 20-port switch, I can add 18 devices on there, plug in the two cables into LAN A, LAN B, still communicating, everything's happy-go-lucky. So this is supported in redundancy. Big caveat on there, you have to be at version 31 of Studio 5000. Like I said, this is a newer technology, so it's something that has only been available on the firmware just recently. So the device level ring stuff, we're down to version 20 if we're doing redundancy on that side, whether we're talking about version 20, 24, 31, or 32 now with redundancy. But on this side, if we're doing parallel redundancy and you need redundant control logics, we'd be at minimum version 31. Any questions? So one of the things, if you guys run across this, a lot of the times what I end up doing is doing a comparison between both. Device level ring will almost always be a lower, cheaper solution. But if you need the bumpless transfer side of it, or you need to have something where it's more of a switch heavy infrastructure, parallel redundancy might be a good avenue, and it doesn't require as much planning when it comes to the network. But just like a redundant star idea, you need to run double the cables. So you just have to kind of weigh the benefits on that side of it. But if you're thinking of just, I need a simple network and I'm okay running a ring, my device level ring, because of the fact that I can minimize the number of switches and I can tie in and do a daisy chain and I can mix and match between fiber or copper connections, it's usually an easier benefit on me. And I can, up to 50 devices, I can qualify you at that 3 milliseconds time. And the 50 devices isn't really a hard limit, but that's kind of where we test it to keep within bounds of that 3 milliseconds. So for the people on the phone, I might go a little bit long, but you're welcome to stay and ask questions. So this is my last slide. All I was going to do is kind of regurgitate some of the stuff that I've been telling you guys and kind of point out a few things that we didn't talk about that might also be part of your network side of it. So more and more things have smart devices connected to it. Almost everything is Ethernet based. On a Rockwell side, everything that we come out with is Ethernet first now. So we'll have almost everything has the dual ports. So a majority of our equipment, from power, components, controllers, all have that dual port option. Our Contrologies DL8s now have a gig port on the front of it. So we're kind of force feeding you into an Ethernet based design. We have methods of being able to convert DeviceNet, ControlNet, Bluehost, all to an Ethernet based network. So if that comes up, let us know, we'll look at it. The big thing is, for anything that's process-based, anything that's a larger and complex network, we want to push for a managed switch design. If you don't need the complexity, but you want the diagnostics, the Stratix 2500 is an entry-level managed switch with all the bells and whistles. You still get quality of service, you still get the DHCP, so the IP address scheme. You just can't do the complex designs like a ring or a redundant star. It's either a 5-port or an 8-port copper network. So if we manage switch, that might be something that we can look at. You kind of want to start looking at how that traffic is affected with the rest of the network design. So are you incorporating any other smart devices that don't care to the control network, something that you don't want to affect what you're doing at your pump control or anything else on that end? And how do you want to do that tying in from third party to non-third party equipment? So one of the big benefits that Rockwell has is when we're looking at the Contrologies, all those Ethernet adapters that I was talking about, we do what's called SIP bridging. So via the backplane, I can go in one Ethernet adapter, go via the backplane and go out the other Ethernet adapter. If you guys have ever done ControlNet, DeviceNet, you've done this all the time. If you've used our like RS Links or any of those, you know that you can kind of go through Studio 5000, connect via one adapter, and then see all of the IO underneath. That's essentially what we're doing there. So we have the benefit of being able to do that segmentation and then still see it as one big network. If we're doing it from the managed switch side of it, and we want to do that segmentation, we need the router. So you'll see at least one layer 3 switch that's a little bit more of an expensive switch, but it allows you to do the routing. And then everything underneath may be a layer 2 switch. Do you need redundant paths? Do you need redundant switches? Do you need redundant controllers? It all comes down to your application. So depending on what you guys are looking at, what the need is, what the overall budget is, you can kind of look to see where can we cut cost when it comes to, you may not need redundant controllers because at no point are you going to be doing updates to it. Or maybe you don't need redundant switches, you just want to be able to do redundant Ethernet connections. So we can kind of minimize that. We'll look at it versus maybe there's a wireless connection, or do you need to do any firewalls? So we didn't really talk about firewalls, but just know that in most cases, firewalls are put on the network to not necessarily segment a piece of traffic, but essentially put a wall around it and force it so that you're only communicating one way or another on specific things that you guys are comfortable with. So again, think of like, again, Ethernet IP on the Rockwell side or Modbus communication. You can ignore everything else and just open up that one specific option that allows you to do Modbus communication or Ethernet IP communication. And you put a wall and a border around everything else. So if you guys have any security questions or anything like that, it's kind of one of the things that I focus on. We typically don't see this on process control network side of it, but we do something called SIP sync or time synchronization. The biggest reason why this is important for you guys is if you've ever tried to have an alarm system and you have multiple alarm systems all throughout, if they're all on a different time base, all of your alarms are messed up. So typically on the computer side of it, a domain controller will send the time synchronization to every single computer that you have on the network so that they're all matched up and everything's tied in. But if anybody's ever gone to your panel view or to your controller, a lot of the times the clock or the wall clock that's on there is all messed up. So what we do is for motion-based applications or precision-based application, we have what's called time synchronization, and it makes so that every single one of the controllers has the same time and date stamp, and it also has propagation delays so that when I send a command through a controller to a peer-to-peer network, it accounts for any delay that goes through. On the low-hanging fruit side of it, what you can do is make it so that your managed switch network, your controllers, and all of the server equipment are all on the same timestamp. So that when you record data on Historian or when you see alarm and event information, they're all on the same timestamp. The easiest thing to do there is there's a clock update tool that we provide or a clock synchronization tool that we provide as part of Studio 5000. It's a free little tool that you can sit on your computer, and it will take the same information that's part of your server system and push that into the controllers, or vice versa. We actually have a tool that will take the time that's coming from the controllers and push that to your servers. So if nothing else, make sure that when you have that, you kind of decide how you want to do that so you don't have the system of multiple different timestamps all over the place. Wireless and mobility. We have Thin Manager. We have different guidelines when it comes to being able to do mobile platforms. We have multiple Encompass partners that are now doing class 1 Div 2 tablets, mobile phones, cell phone, things of that nature. So if that's something that you guys are looking at, let us know. We can kind of help you figure out what makes sense, how you want to go across that, and how do you want to get that information as you start, whether it's a driver-owned program or just being able to see that. The information that Wayne's going to do on the AR, that augmented reality, that plays a big piece of it too, because a lot of times you can overlay information on top of equipment that's already there, but you need a wireless tie-in for it in most cases. Security, I kind of already touched on. That one takes a lot longer as a discussion. The other big thing is network address translation. This one's kind of another one of those low-hanging fruits. If you have a piece of equipment that you're getting into your facility and you don't want to change the IP addresses, but you want it to match the IP address scheme that you have on your network, one of the options that you can do is put a network address translation box in front of it. And there's a little table similar to what I was talking about with that device, DHCP. You can set up a little table that says this IP address looks like this IP address to the rest of the network. And for an OEM, somebody that's putting out a process skid over and over again, the IP addresses never have to change. They put this little box, they put a table on it, and then when you tie it into your network, it all matches your address scheme, but they don't have to do anything on their end. So we can either do this in the Stratic switches. So the 5700, the 5400 already has that capability, but you have to look at the model number. So there's a specific model number that is attributed to it. We also have a little ETAP that it's a 1783 NAT-R that can do up to 32 devices on that device lower ring chain. So basically everything that's part of your device lower ring, this little device is part of it. It has a connection up. So everything within that ring can be in the little table. So there's some kind of scalability options if there's not a Stratic switch, but you have the device lower ring. So if that's a consideration, just make sure that that's something that you're calling out. A lot of it is, do I want to take the engineering time, or do I know what's going to happen if I change the IP addresses, or do I just swap everything out? That was it. I guess it's a little late to say Happy New Year, but. So anybody on the phone still have questions?
Yep, give you a chance to type in. For the guys in the room, we'll be around if you got questions after as well. We'll shut down the web here in a minute. Luis talked about the DLR a bit and had a couple slides. So we actually did a whole hour presentation on DLR back in, I think in July. So I invite you guys to go to our archive and watch that presentation because it got into a lot more detail on DLR ring, and there's a lot of it's a lot more complicated than just make a ring. Not complicated, I mean, it's easy to do, but there's a lot of detail in there that you can learn about on the DLR ring.
Everything is easy. It's okay.
So yeah, it's not complicated. I promise you that.
Yeah.
But
If it works, it should look like this.
yes. So I invite you to go back and watch that one. But that was a good topic, specifically on DLR ring. And looks like it's quiet on the web, so we'll go ahead and shut it down.
Sounds good.
Appreciate
For everybody on the
Luis.
phone, thank you for joining.
Yep. Thanks again, and we'll meet you guys. So February we'll be off site, but we'll do the web simulcast as well. So if you're free to come and join us, great. If not, get online and listen. So appreciate everybody's time. Thanks.